First, to calculate the average and the standard deviation. From these values, the coefficient of variation can be easily calculated. The coefficient of variation is a measure of how large the standard deviation is compared to the average. Now to present these results as a percentage formatted to 1 decimal place. And we can see that sample B4 has returned a coefficient of variation that is outside the range. First, to stack the data into a single column, then I'll draw a quick plot which will help observe if there are any outlying values. This point will need to be removed from the data set as per the instructions. I will cut and paste and then delete the in-between cells and shift the rest upwards. Now to draw the scatter plot for the remaining data. And let's format this one to 2 significant figures. And it's clear to see there's a downward trend in the data. Note the 3SD limit at 265 milligrams per deciliter and also the 2SD level at 260 milligrams per deciliter. We are running a control sample with each batch. So the first 2 batches you can see have come in control. The third batch measures at 255, that is in control. Batch 4, 243. Batch 5 is 254, so all good as expected. So the first 5 batches are all good and can be accepted. And then the control sample at batch 6 throws a warning. Seven is good, and then another warning during batch 8. We're getting a lot of warnings, more warnings than you would normally get. The expected warnings rate is 1 in 20. The batch 17 control sample is above the upper control limit, and that batch will need to be rejected. First, to calculate the all-important slope and intercept parameters. Now to plot the XY scatter to observe the straight line relationship between concentration and conductivity. Concentration, which is our measurement standards, always goes along the x-axis, and conductivity goes on the y-axis. Now for sample 17X with a conductivity reading of 6.83. So here we're analysing a site for contaminated soils, contaminated by chromium. First, let's summarise the data by finding the maximum, the minimum and the mode of the data set. observe a maximum value of 44 ppm. The most common result is 18, and the lowest value is 2 ppm. Now just to center the data, and now to locate the location for the maximum and minimum values. We see they both come from pit 26, the maximum at 0.5 meters and the minimum value at 1 meter, curiously enough. Now to sort the data to find the sites with the maximum contamination. Do this by sorting largest to smallest, and then at the head of the list will be the 5 largest values, and these are found in the pits as indicated here.